Welcome back. In this lecture, we will try to understand what is Apache Spark and what Apache Spark is not. Why do we need something like Databricks or any other platform for designing and developing enterprise grade data engineering solutions or implementing medallion architecture? So, let's start. So let's start with introduction to Apache Spark and try to understand what is Apache Spark. Apache Spark is an engine for executing data engineering, stream processing, and machine learning on distributed clusters. That's what Apache Spark is. And it offers all this through a variety of interfaces or capabilities. The first one is Spark SQL, which is ANSI SQL compliant, batch processing APIs, also known as data frame APIs, stream processing APIs, known as structured streaming, graph processing APIs, machine learning APIs, all this on a single framework. Who is using Apache Spark? Thousands of companies. Literally thousands of companies are using Spark, including 80% of the Fortune 500 companies are using Apache Spark. If you try to understand the Spark stack or the architecture, so at the bottom, Apache Spark is a framework which runs on a distributed cluster of computers, right? It is a framework which runs on a cluster of computers. And for executing Apache Spark on a cluster of computers, we need some kind of cluster manager or cluster operating system, or simply called cluster resource manager. There are a variety of resource managers supported by Spark, including Yarn, Standalone, Kubernetes, Mesos. So Spark framework runs on the cluster of computers using these resource managers. And for reading or writing data, it's a data processing engine, right? It allows us to do the data processing. So for reading and writing data in terms of storage, Spark can integrate with HDFS, S3, ADLS, Google Cloud Storage, etc., a variety of distributed storage systems. So that's how things are stacked for Spark framework to work. On top of the core Spark framework, Spark offers Spark Core APIs. These are the APIs that we as a data engineer or application developer can use those APIs. These are also known as Spark RDD APIs. And these APIs are available in 4 languages like Scala, Java, Python, and R. But these are the core APIs not recommended for direct use, and that's why Spark has developed some more advanced and generalized and simplified APIs for data engineering or data processing activities. The most popular one are Spark SQL and data frame APIs. Then we have Spark structured streaming APIs, MLlib APIs, and GraphX. So that's how the Spark stack looks like. Why Spark is so popular? Here are the reasons. Spark offers you a great level of abstraction. It hides all the complexities of distributed data processing. We simply write simple SQLs or data frame APIs without even realizing and knowing that data will be processed in parallel using the distributed data processing engine, which is Spark framework, on a cluster of computers. All those complexities are hidden from end users or the developers or the data engineers. That's the abstraction Spark offers. It's easy to use. You can use Spark SQL, the simplest interface for developing Spark applications, or you can use different types of APIs available in different languages. It's a unified platform because a single platform offers you a variety of capabilities. You can do SQL, you can do data frame processing, batch processing, stream processing, machine learning, graph processing, all on a single unified Spark platform. It's open source. That's the biggest advantage. And it also offers a wide ecosystem. So since it is open source, a lot of companies collaborate in the open source project, and they develop a lot of different kind of integration and capabilities with their tools. So Spark ecosystem has a wide ecosystem of integrations already available and developed so far. And that's why Apache Spark is super popular for data processing and especially big data engineering activities. So we understand what is Spark and why it is so popular. But what Spark is not? What is Spark not? Let's try to understand that. There are many things that we need for developing an enterprise grade data engineering solution. And all those requirements or all those capabilities are not part of the Apache Spark, the open source Apache Spark. There are things that are missing. I've not listed all those, but here are 5 most critical things that you need in enterprise grade data processing or data engineering applications, which are missing from Apache Spark. Apache Spark doesn't come with the data storage infrastructure, right? It doesn't have its own storage layer. It always requires integrating with some other storage solution like HDFS or Amazon S3 or ADLS. So that's not part of the Apache Spark. Apache Spark doesn't come with the ACID properties, ACID transaction capabilities. I hope you understand ACID properties. ACID is atomicity, consistency, integrity, and durability. Right? This is one of the most critical and essential features of any data system. And Apache Spark does not have its own capability to ensure ACID compliance. We can integrate some other solutions with Spark to bring ACID capabilities to Spark, but it's not part of the Apache Spark project. Apache Spark doesn't come with a robust centralized metadata catalog. It has its own small simple catalog, but it doesn't come with a robust proper centralized metadata catalog. So that's a missing feature from Apache Spark. Apache Spark doesn't come with the cluster management capabilities. We cannot create clusters, we cannot destroy clusters, we cannot manage clusters using Apache Spark. Apache Spark doesn't have that capability. That's part of the cluster management system or cluster resource manager. So that's missing from the Apache Spark. In an enterprise grade application, we typically want to automate a lot of things. Lot of things need to be automated. Apache Spark does not offer a good set of automation APIs or SDKs or command line tools to implement a lot of project automation activities. So those things are missing, right? So the point is simple, super straight. Apache Spark is most popular data engineering, especially big data engineering tool, but it's not complete in itself. It requires a lot of additional capabilities and features to be adopted for a good enterprise grade data engineering solution. And that's where a variety of Spark platforms comes into play. So let's talk about some of the popular platforms. I've listed 5 platforms here. At the top, we have Cloudera Hadoop platform, which is a Hadoop platform. But Spark runs on Hadoop also. So Cloudera Hadoop is the most popular on-premise Hadoop platform, which can be used as a Spark platform. So you have a Cloudera Hadoop platform as a Spark platform. Then we have 3 offerings, almost similar, by 3 major cloud vendors or cloud service providers. Amazon offers a Spark platform known as Amazon EMR. Azure offers a Spark platform known as Azure HD Insight. Google also offers a cloud-based Spark platform known as Google Data Proc. And last one is the Databricks platform. So these are the 5 commonly used or the popular platforms which we can use to develop and manage enterprise grade data engineering solutions. But what is the difference? Right? Cloudera Hadoop platform is the most popular platform for on-premise Hadoop clusters and on-premise solutions for Spark applications. These three are based on Hadoop technology. Behind the scene, all these three runs on the cloud platform, but behind the scene they use Hadoop technology, and the cluster manager for all these are mostly Yarn. So they use Yarn resource manager, and behind the scene they launch Hadoop cluster on the cloud to offer the Hadoop capabilities. And since Spark can run on Hadoop platform, you can use these platforms for Spark application. So basically all these four are behind the scene based on the Hadoop technology, Hadoop platform. Databricks is different. Databricks is a on cloud offering or an on cloud Spark platform. It's purely Spark platform. It is free from Hadoop. What it means? Databricks platform is not based on the Hadoop technology. It does not run a Hadoop cluster behind the scene. It does not use Yarn resource manager behind the scene. It's a complete Spark platform built on the cloud for the cloud using completely Spark technologies and cloud native capabilities. So Databricks is the most popular, most powerful in today's world Spark platform for developing enterprise grade data engineering solutions on the cloud. As of now, Databricks platform is not available for on-premise solutions. So Databricks is purely on cloud, cloud native Spark platform. So that's all. Hopefully you now understand what is Apache Spark, what Apache Spark is not, and why we need a platform like Databricks. We also talked about some other popular platforms in the industry, but this course is all about Databricks. So we will learn about the Databricks platform. See you again. Keep learning and keep growing.